So in the last video, we talked about exponents. And I told you that we would talk about logarithms next. But what is a logarithm? Real quick, I'm just going to go ahead and fill out an equation. It says 2 to the what is equal to 32. I'm actually going to switch pieces of chalk to a yellow one, because that one's getting small and starting to hurt my hands. So this question, we could solve that to get question mark is equal to 5, but we could also rewrite this entire question as log base 2 of 32, because the logarithm takes a base and like a number to take in for the function and says, what do I need to raise 2 to in order to get 32? So the log base 2 of 32 is equal to 5, because you need 2 to the 5th power is 32. This can be extended, of course, to other bases. So like log base 10 of 1000 equals 3. I think you're going to see, because 10 to the 3rd power is 1000. If we wanted to get fractional, we could say log base 4 of 128 is equal to 3 1/2, because 4 times 4 times 4 times 4 to the 1/2 equals 128. Because it's 2 to the 7, so it's 4 to the 3 over 2. Sorry. 3 1/2. So here's some fun things about logarithms. Because of the rules of exponents, where addition becomes multiplication, where multiplication becomes addition, logarithms have an opposite effect, where addition becomes multiplication. So we have a to the b times a to the c equals a to the b plus c. You remember that from exponents. Logarithms have the opposite property. Log a plus log b equals log of a times b. Exponents have the property that a to the b raised to the c equals a to the b times c. Logarithms have the opposite property, that log a times log b is equal to, well, actually, hold on, before I say times log b, I'm going to just say log of a times b equals log of a to the b. I find that interesting. And if you say log without a base, that can mean one of a couple of things. If you're saying this right here, this means that it works in any base. Depending on what field you're in, you're going to find different bases as the standard notation for log. So if you ask a physicist, what does log mean? They will assume you mean log base 10, because we use the metric system when we're working on physics things. So we want things in terms of how many powers of 10 they are. If we talk to a computer scientist, computers use binary, which is base 2. So they say log, and they assume that you mean base 2. If you talk to a mathematician, we use E, which is Euler's number. So whenever we say log, we typically mean log base E, which is also written as natural log, or ln, like log natural. We use that because it makes a It makes a lot of things make more sense when you get to calculus. Let's see, are there other exponent rules that I'm forgetting? Well, these are kind of the two initial ones that give us the first kind of glimpses. I guess we could do some fractional stuff to say. I'm going to start on the log side here. Log of A divided by log of B equals log base B of A. Because that means the power you need to raise something to get A divided by the power you need to raise it to get B is the power you're going to need to raise B to get A. So let's think like computer scientists for a moment and say log base 2 of 64 divided by log base 2 of 8 is going to be 6 over 3, which is equal to the log base 8 of 64, which is equal to 2, of course. So that means that 2 to the third is 8, 2 to the sixth is 64, and 8 to the second is 64. That's kind of an example of working that out. I'm sure there's a parallel exponent property that's not coming to mind immediately, but since you've already had both algebras, you should be fine with that. Either way, we're going to be working a fair amount with these in this class, and I want you to enjoy them because this is one of my favorite parts of math. So I'm actually going to teach you some things going forward in this course that you're probably not going to learn anywhere else because I had to derive them myself because I didn't like the way that they were taught in my class. So they're going to save you some time if you can follow along to what I'm doing because it should also make things a little bit simpler than they're normally taught. So have a good day, guys.